ratio. What does partition mean?
Split.
Split.
Ah.
Split.
Is that my pencil? Where's my house? Ah. She's never got the bag.
No, don't put it in there. Put it up.
Why not?
Just leave the pie. You don't have to ask if I do. Like yesterday.
Remember, she's keeping count of
We want that.
Yeah, too bad we only give him like $1.
Okay. Let's take a look at today's notes. All right, so number 1, we're given points A and B. Point A is the point -3, 4, and B is the point 4, 4. And we're asked to graph the line segment. So let's do that first. Put a point. Whoops, change color. And connect the two. Huh, that's not what I meant to do. I thought I just changed it. Oh, I didn't change the right one. That'll work right now. All right. So, there's our segment, AB. Now, normally we would have to use the distance formula to find the distance from point A to point B, but this is a horizontal line. We're going to mainly focus on horizontal and vertical lines. If we were to partition any other line, it's a little more complicated, and I don't believe your standard is asking us to do that. So we're just going to focus on these. We've already learned how to partition a line. How have we already learned how to do that? Bisecting, using the what? Midpoint. We already know how to do that. So now we're just going to look at some other ratios. So, go ahead. We just want the distance of this one, which we can basically look at and count. Remember when we talked about it the other day? If you're with a horizontal line, all you have to do is the absolute value of the difference in your x's, if it's a horizontal line. So, what is the distance of AB? 7. Okay, so what is the distance, what distance is 2/3 of AB? So you would just take the 2/3 and multiply it times the 7. So this is what these steps are down here. So we would have 4 minus this is the 7, and 2/3 of that is 14/3. That's what we just did. The distance can be found as the difference, the absolute value of the difference in your x's. All right, so this is our horizontal line here. We already know the y. Why do we know the y? Because it's horizontal. The y value anywhere on that segment is what? 4. So all we're looking for is this x. That's all we're missing, is the x. So we know the y is 4. I could go ahead and plug that in. 4. Now, we know that 2/3 of the whole segment is 14/3. So I want to start from A, because we want it to be the AP. Start from A and find a point P somewhere on here that's a distance of 14/3 away from A. How would I do that mathematically?
You plug it in as a distance.
Okay, so basically shift 14/3 in this direction.
Translate it.
And I know that this point is, well, it kind of is thinking that way. -3, 4, and I want to go 14/3 that way. So what would I do?
Translate it.
By
14/3.
add with the 14/3.
Adding
Adding it to what?
And
Yeah. So -3 plus 14/3.
correct.
Yep. So this -3 is the same as -9/3. So -9/3 plus 14/3 is 5/3. So 5/3 is about 1.2 3? A 1 2/3, 1.6. Sorry, 1 2/3. So does that look like it's about 2/3 of the way from there to there? Yeah.
Oh, yeah.
That looks pretty good.
Definitely.
The point is 5/3, 4. That's the ordered pair right here. 5/3, 4. Is the point that partitions the segment. Now, I could ask this same question, but say do it in a ratio of 2 to 3. Not 2 to 3, 2 to 1. Is that true? If this is 2/3 and this is 1/3, is this 2 to 1? Yeah. Now, how did I know this one was 1/3? Yeah, the whole segment is 100%. So if you take 100% and take away 2/3, then you're only left with 1/3. Good. All right, let's look at the second example. All right, given A is a point, 3, 7, and B is 3, -5. So 3, 7, 3, -5. What is the distance between these two lines?
12.
12. So this time, instead of 2/3, I want to do 3/4. Find 3/4 of that distance. So 3/4 of 12 is
8. No, yes, 8. No, not 8. What am I saying? It's 9.
8.
She said
9.
8 too. I
9. Okay. So if you remember, you can put that over 1. You can either multiply your numerators straight across and then divide by the product of your denominators, or you can simplify and say 4 goes into 12 3 times, and 3 times 3 is 9. So a couple different ways to do the algebra there. All right, now when we look at this time the x value doesn't change. What is the x value? 3. So we know the x value has to be 3. And this time we want it to be 3/4 of AB from which vertex this time? B. So we want to go 3/4 of the way up. So if we're going 3/4 of the way up, what do we do with that 9?
Add it.
Add it to the -5. So you do -5 plus 9. So you get 4. So let's do 3/4. Does that look like it's about 3/4? Yeah. And we could even partition this. Go ahead and show you what it looks like. Do you see that divides it into 4 equal parts? Is this 3 of them? Yes, it is. All right. Questions about 1 and 2. You try 3 and 4. 5 is this. So hold on a second on 5 and we'll do it together.
Oh, we don't have.
About what?
Transcript.
Okay, our class goes to our guidance appointment on February 5th.
Oh, that's right. Oh, so it was still.
So you guys will get everything that everybody else is getting, just not.
In 11.
Yeah.
Dang.
I'm sorry.
Dang.
It's okay.
It's probably like 40 or something.
It's okay. Okay, what'd you guys get for number 3?
-4, -2.
-4, -2. Okay, the way we get this is the distance is 12. So 1/3 of that would be 4. Okay? And because we're moving left to right, if we look at this, if we kind of sketch it out and go from here, that wasn't a good place to put. From here to here is our C and D. And we know it's 4 units this way. What am I doing with the 4? Adding it to my X. So -8 plus 4 is how we got that. Okay? All right, the next one is -1, 9.
Dang.
All right, let's look at it.
I don't know how you got
The distance is 20. So 4/5 of that would be 16. All right, when we think about this one kind of looks like this. This is our E. This is our F. So we want to go 16 up from F because we want it to be PF. So 16 up from here. Wouldn't that be adding 16 to our Y? So we take the -1, -7, 16 to that Y. And that gives us our point. Okay? All right, let's look at the last one. This time it gives us about point A is the point -5, 8, and point C is the point -5, 4. And AC is 3/4 of AB. Find the point B. Okay, so what is the length of AC? 4. 4. Because it's a positive 4 there. All right, so C, which is 4, is 3/4 of AB. So how would we solve this? Now, this has happened a couple times today. Here's another example, guys. If we were to have a fraction times our variable, which in our case is AB, what we don't know, the unknown is the length of AB for us, just like the unknown in this equation is X. Do you guys remember that what you do is just multiply by the reciprocal? Multiply by the reciprocal. Whenever you have a fraction, you multiply by the reciprocal. So we get X equals 15/2. What will we do in this case? Multiply it by 4/3. So we'd multiply by 4/3 on this side. And when we multiply by the reciprocal, whenever we multiply by reciprocals, everything cancels and just leaves us with 1. So here we get AB. The length of AB is 16/3. Okay, so we know the whole thing is 16/3. From A all the way to B. Now we just have to figure out, are we adding that to A? Are we subtracting that from A? What do we do?
Subtract it.
Subtract it. Because if we think about it visually, -5/8 is A, and C is -5/4. So B would have to be somewhere down here, wouldn't it? Somewhere on this side. If AC is just a portion of AB, wouldn't it have to continue this way? Okay, so we're going to do that, the 8 minus 16/3 to get the Y value down here. So I would rewrite 8 as 24/3, and that gives me 8/3. So the point is -5, 8/3. And there's my B. Because we want it to go this way, instead of adding it to the y value, to go down, we subtract. Okay. Now's your time to either finish up your project or go ahead and start working on the back. Okay?